Hi guys, in this video I'm gonna talk about cross-validation and key-fold cross-validation in machine learning. Before building a classic machine learning model, we split our initial dataset into training and test datasets. We built the machine learning model using training dataset and evaluate this model using test dataset. This technique is called holdout method. But to obtain a good model, you need to tune the hyperparameters of the model. This process is called model selection. If you reuse the same test dataset over and over again during model selection, the overfitting problem can occur. The models which have overfitting problem are called complex models. If you have a too complex model for a given training dataset, you can't generalize well the model to unseen data. A better way to a good model is to separate the data into three parts: a training dataset, a validation dataset, and a test dataset. You can use the training dataset to build the model. You can use the validation dataset to tune the hyperparameters of this model. Lastly, you can evaluate the model using test dataset that the model hasn't seen before doing the training and model selection steps. To obtain the validation dataset, you can use key-fold cross-validation technique. In this technique, you randomly split training dataset into key-fold without replacement. Here, you can use key minus one fold for model training, and you can use one fold for model evaluation. This produce is repeated key times. So, you obtain key models and performance estimates. To find the performance of the model, you can calculate the mean performance of the model based on different test folds. You can use cross-val score method in scikit-learn for key-fold cross-validation. Let me show this using a real-world data. What I'm going to use the dataset is breast cancer Wisconsin dataset. You can find the link for this dataset in the description below. I'm gonna load this dataset with pandas. First, let me import pandas. Import pandas as pd. Let's load the dataset. df equals pd.read csv. Let me set the dataset name wdbc.data. This dataset has no column name. Let me use header equal none. Cool, our dataset loaded. Let's take a look at the first 5 rows of the dataset. df.heat. Here you go. This dataset includes malignant and benign tumor cells. The first column in the dataset shows the unique ID numbers, and the second column shows diagnosis. The rest of the columns are our features. Let's take a look at the shape of the dataset. df.shape. You can see the numbers of the rows and the columns. Now, let's create the input and output variables. To do this, I am gonna use the log method. First, let me assign the features to the numpy array. X equals df.log comma 2 dot. To convert a numpy array, let me set values. Okay, now let me create the target variable. Y equals df.log comma 1 dot values. Beautiful, we have created the variables. Our target variable has two categories, M and B. But scikit-learn doesn't understand to be categorical of this variable. We need to say that this variable is categorical. Let me use label encoder class. First, I'm gonna import this class from sklearn.preprocessing import label encoder. Now I'm gonna create an object from this class. le equals label encoder. Let's fit the transform our target variable. Y equals le.fit transform. Let me set y. Awesome, we transformed the class label into integers. Before building the model, let's split the dataset into training and test set. To do this, I am gonna use the train test split function. First, let me import this function from sklearn.model selection import train test split. Let's split our dataset using this function. X train, X test, Y train, Y test equals train test split. Let me set the variables X, comma, Y, comma. To split the dataset in balanced, let me set stratified equals Y, comma. For reproducible output, let me set random state equals 0. Cool, our datasets are ready to analyze. Next, I am gonna use a pipeline for data preprocessing and model building steps. Let me import the classes used for these steps. First, to scale the dataset, I am gonna import standard scaler class from sklearn preprocessing, import, standard scaler. For dimensionality reduction, I'm gonna import the PCA class from sklearn.decomposition import PCA. To build the model, I'm gonna import logistic regression class from sklearn.linear model import logistic regression. To use the pipeline, I'm gonna import make pipeline from sklearn pipeline import make pipeline. The make pipeline creates a pipeline for us and automatically names each step. Now let's create an object from make pipeline. Pipe equals make pipeline. Let's set the first step. Standard scaler. After that, for dimensionality reduction, let me set PCA. For n components, I am gonna give 2. Lastly, let me set the model name. Logistic regression. Beautiful. We built a pipeline. Now, let's train our estimator using cross-val score function. First, let me import this function from sklearn.model selection import cross-val score. Next, let's use this function. Scores equals cross-val score. First, I'm gonna pass our pipeline. Estimator equals pipe. Let me set training sets. X equals X train. Y equals Y train. Let me specify the number of fold. A good standard value for key in key fold cross validation is 10. I'm gonna give 10. To use all available CPUs on our machine during the model training, let me set n jobs equal -1. So we trained our estimator with key fold cross validation technique. Now let's take a look at the scores. I'm gonna write scores. Here you can see 10 scores due to using 10 folds. So we calculate the scores for the models based on the different independent test folds. What happened? Let me explain. The training dataset is divided into 10 folds, and during the 10 iterations, 9 folds used for training and 1 fold used as the test dataset for model evaluation. Note that we found the scores for each 10 folds. To see the performance of the model for all 10 folds, let's calculate the mean of the scores. I am gonna use the mean method in NumPy. Let me import NumPy. Import NumPy as NP. Let's take a look at the mean of the scores. np.mean scores. Here you go. The mean score of our model is 0.95. So we evaluate the model using cross-validation technique. In short, because of using all data points, key fold cross-validation makes better use of the dataset than the holdout method. That's it. I hope you enjoy it. In this video, I'll talk about how to use the cross-validation in machine learning. Thanks for watching. Don't forget to subscribe to my channel, give a like, and leave a comment. See you in the next video. Bye for now.